little bit about Berger. Who are we? Berger was founded in Germany almost 70 years ago by my father. We've been in Canada now for a bit over 40 years. In total, we have a bit more than 350 million US dollars in annual sales. Facilities in Germany, Canada, the US, Poland, and China. Globally, over 2,500 employees, almost 100,000 square meters of production space, 10,000 here in Brampton, and over 1,000 manufacturing machines in service right now. We talked briefly about cybersecurity. The latest certification that we have strived for is ISO 27000, which is currently a certification that you can get also in Canada for cybersecurity. CMMC is a little bit more tricky to get here in Canada, but it's something we're looking at as well. Berger is founded on essentially three pillars. It's people, it's technology, and it's sustainability, which has allowed us to be in business for the length that we have been around. Since this is all about technology, I want to take a few moments to talk about the other two pillars, people and sustainability. Specifically about our location here in Brampton, we've been certified specifically for workplace quality, training, and the soft skills by third party, and I think we scored amazingly, and I'm extremely proud of our team. Our team is also the one that actually every day makes happen what we do. For our Canadian facility, our goal is to be level 1 and level 2 carbon neutral by 2026. So besides the engineering that goes into making parts, there's a lot of engineering that also goes into making a facility environmentally friendly and carbon neutral. A bit more now about the technology aspect of what we do. We machine metals. Primarily, we turn and mill, grind, and various other operations that come with that. We have parts that are less than 3 millimeters in size. We have parts that are greater than 3 meters in size. We have parts with over 200 dimensions. We have tolerances that we machine today that are less than 1 micron. Annual volumes might be 1 part, it might be 36 million parts. And everything is under the premise zero defect for our customers. It drives a lot of complexity and a lot of aspects that you have to control within the process. Through the history of our organization, machining has changed, specifically the way quality and production is generated. We started out with mechanical control. Essentially, it was the age of the artist, where the machine operator was also the mechanic that knew how to fix the machine, and most of your quality was driven through the operator that was actually making the part. In the 1970s, we started to see NC control, where now there is computer or electronic aids to help with consistent machining. The parts, incidentally, also became more complex. Towards the end of the 1980s, we saw CNC control, where now the machine is much more flexible. The machine does a lot of the work, and the operator has less of a responsibility on the actual touching of the part to part, but also the operator has a lot less understanding in regards to what the machine does and to fix it. So this is also a time when you have a lot more specialization in regards to maintenance, in regards to setup and production. The last 20 years, there have been a lot of buzzwords. The biggest one, I think, and there's one right behind me, it's Industry 4.0. I want to focus my brief talk about Industry 4.0 and the value it has as a precursor to an AI-driven manufacturing environment. In 2014, in our Canadian facility with our team, we started developing a one-piece flow production system for a new product. And essentially, we wanted to have one-piece flow, be fully automated, automatically adjust processes, have 100% not part, but process traceability, zero WIP inventory, and 100% first-time quality. It took us about 2 years and a lot of gray hairs to develop this concept with our suppliers. Oops. What you see on the picture is actually a picture of the actual equipment. What we learned was, first of all, when the buzzword arrives, the technology hasn't arrived yet. So you have to find partners and create an ecosystem to actually make the buzzword or the theory reality. The second thing we learned is it's supposed to be very cost effective, but if you're at the edge of technology, initially it's extremely expensive. So this production line on its own for one product was $10 million. We wanted to have a lot of data capture, so we capture 50 process parameters for every one of the 8 production steps that are integrated into this production line. We needed to understand how we capture the data. We needed to understand how we move data from equipment to equipment. We needed to understand how we use this data and feed it back to previous processes to make automatic adjustments. And we had this great idea, if we have all this data, we can do amazing analyses. This is where we get to a point where the idea was there again, but the cost of going and implementing it up to today has been extremely prohibitive. We have over 1.5 billion data points from this production line, and to get the data analyzed is extremely expensive. Since 2014, when we implement this production line, all the additional production equipment that we have procured all followed the same methodology. We needed to be able to automatically capture data. We wanted to have the data available because we thought next year we will be able to use the data and analyze the data. Which now we have the big cloud, we have lots of data, and we're having the conversation now about artificial intelligence in manufacturing. So for me, I think one of the key learnings is, first of all, you need to have the precursors in place in order to move forward. So when we think about artificial intelligence in manufacturing, you have to have the structures in place and you have to have the systems in place to collect a lot of data, because AI is based on running a lot of data. The second aspect is, I feel like 2014, we have the ideas, we know what we want to do. We now have to put together a consortium of people, of companies, of ideas, and it's going to be very expensive to actually follow through and make these first steps in adapting AI to the true manufacturing process. Just a few more thoughts on that. The first steps will be analyzing existing data. The second step will be feeding back into the machine and automatically adjusting the machines based on the data. The third step will be adjusting the machines in process, so in real time, and eventually, hopefully, we get to the point where the processes will automatically be developed through the existing data set that was developed over the years in the past. That's all I have. Thank you very much, and I'm looking forward to the panel discussion.